below. In this lecture we find out the value of angle theta. In the drawing we have triangle ABC that is an isosceles triangle, that is to say AC equals to CB. In addition, we know that this angle equals to 20 degrees, and we also know that angle NAB equals to 50 degrees in its size, and angle MBD equals to 60 degrees in its size. Repeat again. Triangle ABC is an isosceles triangle, that is to say CA equals to CB. Angle ACB equals to 20 degrees in its size. Angle NAB equals to 50 degrees. Angle MBC equals to 60 degrees. And our mission is to find out the size of this angle, angle theta, that is actually angle NMB. So first of all, we focus on triangle ABC, the isosceles triangle ABC. So I copy triangle ABC in a new page and we will analyze this triangle ABC. AC equals to CB. So this is triangle ABC that I call it from the original drawing. This triangle AC equals to CB, and we have the rule that in front of equal sides in the triangle there are equal angles. So those two angles that are located in front of equal sides must be equal to each other. So if one angle is theta, then the other angle must be also equal to theta. The sum of the angles in this triangle ABC, must be equal to 180 degrees, according to the rule that the sum of the angles in any triangle is equal to 180 degrees. So 20 degrees plus theta is 2 theta. In total, they must be equal to 180 degrees. So we subtract 20 degrees from this equation. And finally we get that 2 theta equals to 180 minus 20 is 160, so 2 theta equals to 160 degrees. We divide this equation by 2, and finally we get that angle theta equals to 160 over 2, it is 80 degrees. So the size of this angle theta is 80 degrees. This is angle theta that is equal to 80 degrees. So in the original drawing, this is angle theta that is equal to 80 degrees. But angle NAB equals already to 50 degrees, so the missing angle must be equal to 30 degrees in order to complete the sum of the size of angle theta to 80 degrees. The missing angle must be equal to 30 degrees. Likewise, this is angle theta that is equal to 80 degrees, but this angle MBA also already equals to 60 degrees, so the missing angle must be equal to 20 degrees. In order to complete the size of angle theta to 80 degrees, this angle equals to 20 degrees. Okay, so in the next step we'll focus on triangle NAB. So I copy triangle NAB in a new page and we analyze this triangle NAB. This angle NAB equals to 50 degrees. This is angle theta that is equal to 80 degrees. So this is triangle NAB, this is a copy from the original drawing. We define the missing angle as theta. In this triangle NAB, the sum of the angles must be equal to 180 degrees, that is to say 50 degrees plus 80 degrees plus angle theta. In total, the sum of those angles must be equal to 180 degrees. 50 plus 80 is 130, so we subtract 130 degrees from this equation, and finally we get that angle theta equals to 180 minus 130, it is 50 degrees. So this angle theta equals to 50 degrees in its size. That is to say, angle A and B equals to 50 degrees in its size. Angle A and B equals to 50 degrees in its size. We continue to focus on triangle A and B. Triangle A and B, those two angles are equal to each other. Again, we have the rule that in front of equal angles in the triangle, there are equal sides. So, those two sides that are located in front, those equal angles must be equal to each other. That is to say, AB equals to NB. AB equals to NB. Write it down here. That side AB equals to side NB. Okay, so in the next step, we'll focus on triangle A and B. This triangle, so I'll copy triangle A and B in a new page and we'll analyze it. This is angle theta that we calculated in the beginning of the lecture, that is equal to 80 degrees. Angle MBA is again equals to 60 degrees. So actually, this is triangle MAB that I copied from the original drawing. We define the missing angle as theta. In triangle A and B, the sum of the angles must be equal to 180 degrees. So 80 degrees plus 60 degrees plus the missing angle that is theta. In total, those three angles must be equal to 180 degrees. 80 plus 60 is 140, so we subtract 140 degrees from this equation, and finally we get that angle theta equals to 180 minus 140, it is 40. Angle theta equals to 40 degrees in its size. So that is to say, angle A and B equals to 40 degrees in its size. Okay, so in the next step, we will draw from point B line segment BD in such a way, we will draw line segment BD on AC in such a way that BD will be equal to AB. So we constructed line segment BD in such a way that BD equals to AB. BD equals to AB according to our construction. BD equals to AB. So from one side, BD equals to AB according to our construction. but we already found out that AB equals to NB. So from those two equations we derive here AB for one side it is equal to NB. But for the other side AB equals to BD. AB equals to BD. From this equation we will derive that BD equals to NB. BD equals to NB. Okay, BD equals to NB. Here, BD equals to NB. Write down here. BD equals to NB. Write it here also. That BD equals to NB. BD equals to NB. Okay. In the next step, I'll copy triangle ADB in a new page and we'll analyze this triangle ADB. We also have already found out that AB equals to NB. Here, AB equals to NB. So I'll copy triangle ADB in a new page and we'll analyze it. This is angle theta that we found in the beginning of the lecture that is equal to 80 degrees. Angle DAB equals to 80 degrees. AB equals to DB according to our construction. And again, this is triangle ADB that I copied from the original drawing. AB equals to DB according to our construction. AB equals to DB. So those two sides are equal to each other. And we have the rule that in front of equal sides in the triangle there are equal angles. So those two angles that are located in front, the equal sides must be equal to each other. But this angle equals to 80 degrees, therefore this angle must be also equal to 80 degrees. So angle ADB equals to 80 degrees in its sides. I'll write it down here. Angle ADB equals to 80 degrees in its sides. We will continue to focus on triangle ADB. On this triangle ADB, the sum of angles must be equal to 180 degrees. So we define the missing angle as theta. So 80 degrees plus 80 degrees plus theta in total, the angles must be equal to 180 degrees. 80 plus 80 is 160, so we subtract 160 degrees from this equation, and finally we get that angle theta equals to 180 minus 160, it is 20 degrees. Here the missing angle theta equals to 20 degrees in its size. That is to say, angle ABD equals to 20 degrees. This is angle ABD. This angle equals to 20 degrees in its size. So here we have the big angle MBA equals to 60 degrees in its size. The small angle DBA equals to 20 degrees in its size. Therefore, the missing angle MBD must be equal to the big angle MBA minus the small angle DBA. Okay, the big angle MBA minus the small angle DBA must be equal to the missing angle MBD. So the missing angle MBD must be equal to the big angle that is actually MBA minus the small angle that is actually DBA. Repeat again. This is the missing angle MBD is equal to the big angle MBA minus the small angle that is DBA. So the missing angle MBD must be equal to the big angle MBA. This is angle MBA is equal to 60 degrees minus the small angle DBA is equal to 20 degrees. Again, MBA equals to 60 degrees and DBA equals to 20 degrees. So the missing angle MBD must be equal to 60 degrees minus 20 degrees, that is 40 degrees. So we found out that the missing angle MBD equals to 40 degrees in its size. The missing angle MBD is equal to 40 degrees in its size. In the next step, we focus on triangle DMB. So I'll copy triangle DMB in a new page and we'll analyze triangle DMB. Angle MBD equals to 40 degrees. And this angle DMB also equals to 40 degrees. So actually, this is triangle MBD, the point from the original drawing. Those two angles are equal to each other, and again we have the rule that in front of equal angles in the triangle there are equal sides. In front of those two angles we have those two sides, therefore those two sides must be equal to each other. That is to say, dm equals to db. dm equals to db. So I write it down here that dm equals to db. Side dm equals to side db. Okay. And in the next step, we join points D and N together by a straight line. focus on triangle, the green triangle, triangle DNB. So I copy triangle DNB. In your question, we will analyze this triangle, triangle DNB. Angle NBD. This angle equals to 40 degrees plus 20 degrees, that is 60 degrees. And we have already found out that dB equals to NB. dB equals to NB. Here, dB equals to NB. dB equals to NB. dB equals to NB. This is triangle DNB that I copied from the original drawing. Angle DBN equals to 60 degrees, and those two angles, those two sides are equal to each other. That is to say dB equals to NB. Again, we have the rule that in front of equal sides in the triangle there are equal angles. So those two angles that are located in front of the equal sides must be equal to each other. So if one angle is theta, then the other angle must be also equal to theta. The sum of the angles in triangle DNB must be equal to 180 degrees. So theta plus theta is 2 theta plus 60 degrees. In total, they must be equal to 180 degrees. You subtract 60 degrees from this equation, and finally you will get that 2 theta equals to 180 minus 60 is 120. So 2 theta equals to 120 degrees. We will divide this equation by 2, and finally you will get that angle theta equals to 120 degrees over 2, it is 60 degrees. So this angle theta equals to 60 degrees in its size, and this angle theta also equals to 60 degrees in its size. So actually found out that in triangle DNB all the angles are equal to 60 degrees. Therefore triangle DNB is an equilateral triangle. So I write it down. Triangle DNB is an equilateral triangle. Okay, again, triangle DNB is an equilateral triangle, and we know that in any equilateral triangle all the sides are equal to each other. That is to say, in the equilateral triangle DNB, dN equals to NB equals to dB. dN equals to NB equals to dB. So I write it down here. dN equals to NB equals to dB. Okay. Now, we found out that dm equals to db. and BD equals to NB. BD equals to NB. So we have here those four equations. dm equals to dB from one side, or dB equals to dm from one side, dB equals to dm from one side here, but from the other side dB equals to dn also. Okay, dB equals to dn. From here we can derive that dB equals to dn. So here dB equals to dn. And from this equation we derive that dm equals to dn. dm equals to dn. dm, this is dm equals to dn. This is dn. So we found out that dm equals to dn. dm equals to dn. In the next step, I will copy the triangle DMN in a new equation. We will analyze this triangle DMN, but before that, we will focus on this side of the straight line CA at point D. Okay? So we have the straight line CA. Point D. On this side of the straight line CA at point D, we have this angle that is equal to 80 degrees. The green triangle is an equilateral triangle, so this angle must be equal to 60 degrees. So this angle equals to 60 degrees. Here, this angle equals to 80 degrees, this angle equals to 60 degrees. So the missing angle, angle MDN, according to the rule that the sum of the angles on one side of the straight line is equal to 180 degrees. So if we focus on this side of the straight line CA at point D, the sum of the angles must be equal to 180 degrees. So 80 degrees plus 60 degrees, it is 140 degrees. Therefore, the missing angle must be equal to 40 degrees. That is to say, plus 40 degrees plus 140 degrees, it is 180 degrees. So the missing angle MDN must be equal to 40 degrees in its size. The missing angle MDN must be equal to 40 degrees in its size. In the next step, I will copy triangle MDN in a new page and we will analyze it. I will remind you that dm equals to dn. dm equals to dn. Repeat again that angle MDN equals to 40 degrees and dm equals to dn. This is triangle MDN that I call it from the original drawing. dm equals to dn. Again, we have the rule that in front of equal sides in the triangle are equal angles. So in front of those two sides that are equal to each other, we have those two angles that are must be equal to each other. So if this angle is theta, then this angle must be also equal to theta. The sum of the angles in triangle DMN must be equal to 180 degrees. A theta plus theta is 2 theta, so 2 theta plus 40 degrees must be equal to 180 degrees. We subtract 40 degrees from this equation, and finally we get that 2 theta equals to 180 minus 40 is 140, so 2 theta equals to 140 degrees. We divide this equation by 2, and finally we get that angle theta equals to 140 degrees over 2, it is 70 degrees. So angle DMN, that is theta, it is equal to 70 degrees in its size. This is angle DMN, that is equal to 70 degrees in its size. It is very easy to see from the drawing that the big angle DMN, this is the big angle DMN, minus the small angle DMB must be equal to the missing angle, that is the angle theta, that is the angle that we are looking for. Again, the big angle DMN minus the small angle DMB must be equal to the missing angle, that is the angle theta, that is the angle that we are looking for. So the big angle DMN, we just right now found out that the big angle DMN equals to 70 degrees in its size. Minus the small angle, that is actually angle DMB. This is the small angle DMB is equal to 40 degrees. Must be equal to angle theta, that is the angle that we are looking for. Angle theta is actually angle BMN. Repeat again. The big angle DMN is equal to 70 degrees minus the small angle DMB, that is equal to 40 degrees. Must be equal to the missing angle, angle theta, that is angle BMN, that is the angle that we are looking for. So the big angle is 70 degrees minus the small angle, that is 40 degrees. So 70 minus 40, it is 30 degrees. So we found out that the missing angle, that is angle theta, that is the angle that we are looking for, it is equal to 30 degrees in its size. Repeat again. This is angle theta, that is actually also angle BMN, that is equal to 30 degrees in its size. In the next step, I'll summarize the lecture. In this lecture, we found out the size of this angle, angle theta, this is actually angle BMN. It is given us the question that triangle ACB is an associated triangle, that is to say AC equals to CB. In addition, we know that this angle ACB equals to 20 degrees, this angle NAB equals to 50 degrees in size, and finally this angle DBA, MBA, this angle equals to 60 degrees in size. Our mission is to find out the size of this angle BMN, that is actually angle theta. So first of all, we focus on triangle ABC. So I copy triangle ABC in the new page here. It is given us the equation that AC equals to BC. This angle equals to 20 degrees. Again, we have the rule that in front of equal sides in the triangle, there are equal angles. So those two angles that are located in front of the equal sides must be equal to each other. So if this angle is theta, this angle must be also equal to theta. And we also know that the sum of the angles in any triangle is equal to 180 degrees, and especially it is true in triangle ABC. So theta plus theta is 2 theta plus 20 degrees, In total, they must be equal to 180 degrees. We subtracted 20 degrees from this equation and finally found out that 2 theta equals to 180 minus 20 is 160. So 2 theta equals to 160 degrees. We divided this equation by 2 and finally found out that angle theta equals to 80 degrees in its size. So those two angles, each of them equal to 80 degrees in its size. This is angle theta that is equal to 80 degrees, but this angle NAB, it is already equals to 50 degrees. So the missing angle must be equal to 30 degrees. In order to complete the size of angle theta to 80 degrees, the missing angle must be equal to 30 degrees. Likewise, this is also angle theta that is equal to 80 degrees. But this angle MBA already equals to 60 degrees. So the missing angle here, angle NBA, must be equal to 20 degrees in order to complete the size of angle theta to 80 degrees. In the next step, we focused on triangle A and B. So I copied triangle A and B in a new page and we analyze this triangle A and B. This is triangle A and B that I copied from the original drawing. Angle NAB equals to 50 degrees. This is angle theta that is equal to 80 degrees. Angle NB equals to 50 degrees, angle NBA equals to 80 degrees, and this is the missing angle that we define as theta. The sum of the angles in triangle A and B must be equal to 180 degrees, so 50 degrees plus 80 degrees plus theta, in total they must be equal to 180 degrees. 50 plus 80 is 130, plus theta equals to 180 degrees. We subtracted 130 degrees from this equation, and finally we found out that angle theta equals to 180 minus 130, it is 50. So this is angle theta, angle NAB, that is equal to 50 degrees. Angle A and B equals to 50 degrees. We continued to focus on triangle A and B. So those two angles, they are both equal to 50 degrees. And we have the rule that in front of equal angles in the triangle, they are equal size. That is to say, those two sides that are located in front of equal angles must be equal to each other. It means that AB equals to NB. AB equals to NB. AB equals to NB. AB equals to NB. Also, appear that AB equals to NB. In the next step, we focused on triangle A and B. So I copied triangle A and B in a new page and we analyze it. This is triangle A and B that I copied from the original drawing. Angle ABM equals to 60 degrees in size. Angle MAB equals to 80 degrees. Angle MBA equals to 60 degrees. MAB equals to 80 degrees. And we define the missing angle as theta. The sum of the angles of triangle A and B must be equal to 180 degrees. So 80 degrees plus 60 degrees plus angle theta, in total, the sum of those three angles must be equal to 180 degrees. 80 plus 60 is 140. So we subtracted 140 degrees from this equation and finally found out that angle theta equals to 180 minus 140, it is 40. So angle A and B, that is angle theta, equals to 40 degrees. Here, this angle A and B equals to 40 degrees in its size. Okay. Then, from point B, we draw line segment BD in such a way that BD will be equal to BA. Again, BD equals to BA according to our construction. Repeat again. Line segment BD that we constructed equals to AB according to our construction. We have already found out that AB equals to NB. AB equals to NB. Here. AB equals to NB. So from those two equations we derive that from one side AB equals to NB. From this equation. And from this equation AB equals to BD. Okay, AB equals to BD. And from this equation we derive that BD equals to NB. See, BD equals to NB. side BD or DB equals to NB. BD equals to NB. Then we focused on triangle ADB. This is triangle ADB. So I copied triangle ADB in a new page and we analyze this triangle, triangle ADB. This is triangle ADB that I copied from the original drawing. This angle equals to 80 degrees, according to what we have already found out in the beginning of the lecture. We define this angle as theta. This is the missing angle. Again, we found out that actually AB equals to DB according to our construction. AB equals to DB according to our construction. Again, we have the rule that in front of equal sides in the triangle there are equal angles. So those two angles that are located in front of equal sides must be equal to each other. But this angle equals to 80 degrees, therefore this angle must be also equal to 80 degrees. Okay? We continue to focus on triangle ADB. The sum of the angles in this triangle ADB must be equal to 180 degrees. That is to say 80 degrees plus 80 degrees plus theta. In total, they must be equal to 180 degrees. 80 plus 80 is 160. 160 plus theta equals to 180 degrees. We subtracted 160 degrees from this equation and finally found out that angle theta, this angle theta, this angle ABD equals to 180 minus 160, that is 20 degrees. Angle ABD equals to 20 degrees in its size. This is angle ABD that is equal to 20 degrees in its size. Now we have the small angle ABD equals to 20 degrees. The big angle ABM equals to 60 degrees. It's very obvious from the point that if we subtract the big angle ABM from the small angle ABD, it will give us the missing angle MBD. Again, angle ABM or angle ABD will give us the missing angle TBM. Okay. So here we have, repeat again, the missing angle, that is angle MBD, equals to the big angle MBA minus the small angle, that is angle DBA. The small angle is angle ABD actually. Small angle is angle ABD. The big angle ABM equals to 60 degrees. The small angle ABD equals to 20 degrees. Therefore, the missing angle is equal to 60 degrees minus 20 degrees, that is 40 degrees. The missing angle MBD, this is the missing angle that is equal to 40 degrees in its size. In the next step, we focused on triangle MBD. So copy this triangle MBD in a new page and we analyze it. This is triangle MBD that I copied from the original drawing. We have already found out, we just right now found out that this angle equals to 40 degrees. Yeah, this angle MBD equals to 40 degrees, and we have already found out that this angle also equals to 40 degrees. So those two angles are both equal to 40 degrees. Again, we have the same rule that the sum in front of equal angles in the triangle they are equal sides. That is to say, those two sides that are located in front the equal angles must be equal to each other. That is to say, the M equals to BD. The M equals to BD. So we can write here that here the M equals to BD. Here also the M equals to BD. Okay. Then we focus on triangle DNB. Actually, first of all, we join points D and N together by a straight line. By joining points D and N, we created triangle DNB. This is triangle DNB. And in triangle DNB, you get DBN equals to 40 degrees plus 20 degrees, that is 60 degrees. This is triangle DNB that I copied from the original drawing, and get dBn equals to 60 degrees. Again, we found out that dB equals to NB. dB equals to NB. Yeah. dB equals to NB. We already found out that dB equals to NB. Okay. dB equals to NB. Again, we have the same rule that in front of equal sides in the triangle there are equal angles. So those two angles that are located in front, the equal sides must be equal to each other. So if one angle is theta, then the other angle must be equal to theta. And the sum of the angles in any triangle is equal to 180 degrees. That is to say, 60 degrees plus theta equals to 180 degrees. Okay, so 2 theta plus 60 degrees must be equal to 180 degrees. We subtracted 60 degrees from this equation and found out that 180 degrees from 60 is 120, so 2 theta equals to 120 degrees. We divided this equation by 2, 120 over 2 is 60 degrees. So we found out actually that angle theta equals to 60 degrees. This is angle theta that is equal to 60 degrees, and this is also angle theta that is equal to 60 degrees. So in triangle DNB we have 3 angles that are all equal to 60 degrees. Therefore triangle DNB must be an equilateral triangle. Okay, again, triangle DNB must be an equilateral triangle. And we know that in an equilateral triangle, all the sides are equal to each other. That is to say, in this equilateral triangle DNB, dN equals to NB equals to dB. dN equals to NB equals to dB. Okay, and we found here that dN equals to NB equals to dB. Then we focused on this side of the straight line CA at point D. We have the rule that the sum of the angles on one side of a straight line must be equal to 180 degrees. So the sum of the angles on this side of the straight line CA at point D must be equal to 180 degrees. So which angles we have at this side of CA at point D? We have this angle that is equal to 80 degrees. This angle equals to 60 degrees. Why? Because it is one out of the 3 angles of the equilateral triangle plus the missing angle. In total they must be equal to 180 degrees. Repeat again. On this side of the straight line CA at point D, the sum of the angles must be equal to 180 degrees. So 80 degrees plus 60 degrees, it is 140 degrees. Therefore the missing angle must be equal to 40 degrees. Because 140 degrees plus 40 degrees, it is 180 degrees. This is the sum of the angles on this side of the straight line CA. We actually found out that angle MDN equals to 40 degrees in its side. Yeah, this is angle DMN that is equal to MDN that is equal to 40 degrees in its size. And then we focus on triangle DMN. This is triangle DMN. And we know, we have already found out here that dB equals to NB, BD equals to NB, BD equals to NB, and DN equals to NB equals to BD. So from one side, BD equals to DN. Here, one side, here, BD equals to DN. Okay, BD equals to DN. But from the other side, BD also equals to DN. Here, BD equals to DN. BD equals to DN. So from this equation, ND equals to DB equals to DM, we will derive that DN equals to DM. DM equals to DN equals to DM. Okay, DM equals to DN. So actually we found out that here DM, let's say with DM equals to DN. Then I copy triangle DMN, and in your project we analyze it. We just right now found out that DM equals to DN. DM equals to DN. And we already found out that angle MDN equals to 40 degrees. Here, angle MDN equals to 40 degrees. Again, the same rule in triangle MDN. In front of equal sides, those two sides are equal to each other, we have equal angles. So those two angles that are located in front, the equal sides must be equal to each other. So if one angle is theta, then the other angle must be also equal to theta. Again, we have the same rule that the sum of the angles in triangle DMN must be equal to 180 degrees. Theta plus theta is 2 theta plus 40 degrees. In total, they must be equal to 180 degrees. In conclusion, we found out that 2 theta plus 40 degrees must be equal to 180 degrees. We subtracted 40 degrees from this equation and finally we found out that 180 minus 40 is 140. So 2 theta equals to 140 degrees. We divided this equation by 2 and finally we found out that angle theta equals to 140 degrees over 2, it is 70 degrees. So angle theta equals to 70 degrees in its size. Angle theta is angle DMN. So this is angle DMN that is equal to 70 degrees in its size. The big angle DMN equals to 70 degrees. The small angle DMB equals to 40 degrees. Therefore, the missing angle, that is angle theta, that is the angle that we are looking for, must be equal to the big angle DMN minus the small angle DMB. Repeat again. The big angle DMN that is equal to 70 degrees minus the small angle DMB that is equal to 40 degrees must be equal to the missing angle theta, that is the angle that we are looking for. It's actually angle BMN. Okay, the big angle equals to 70 degrees, the small angle equals to 40 degrees. 70 degrees minus 40 degrees is 30 degrees. So finally we found out that the missing angle theta, that is the angle that we are looking for, that is also angle BMN, it is equal to 30 degrees in its size. Okay, thank you very much.